Okay, we're checking out the appending to a slice. It's common to append new element to a slice, and so Go provides a built-in append function. The documentation of the built-in package describes append. The first parameter is a function. Oh, I believe we can also. I think I've been using like slices. So for example, number is just a slice of int 1 2 3 4 5, and then number append. So number, what did I just do? I did number and append. So this converts to this function. So it takes a type of slice and then rest operator. The first parameter s of append is a slice of type t, and the rest are t values to append to the slice. The resulting value of append is a slice containing all the elements of the original slice plus the provided values. If the backing array of S is too small to fit all the given values, a bigger array will be allocated. The return slice will point to the newly allocated array. Read the slice usage and internal article. I mean, pretty easy. Like this kind of print slice, which is gonna be like 0 or null. It's gonna be empty, nil, empty slice. Append works on nil slices. Append it appends 0. Slice grows as needed. Pretty easy. Range. The range form of the for loop iterates over a slice or a map. When ranging over a slice, two values are returned for each. Two values are returned for each iteration. The first is the index, and the second is a copy of the element at that index. So we got a variable, a slice of array. So basically, a slice. I'm gonna just call it slice. And we have a variable initial. Okay, so this is just a expression short, so-called short statement, and this is the value that's gonna be like, what is this? So this is the value, and we only have one value, pow. So range pow, what the hell is this? I believe the range, the pow. Range pow. So slice. So range, we give it the value pow, and gives us index and the value. Okay, got it. So to use the for loop with range syntax, I need to use for, and now let's use range and use number. This gives us index and copy of the value. So I'm going to call this item, and now I can just print I and item. Go run. Strings is not important and used. Get out of here, dude. Okay. Great. Pretty easy stuff. Range is good. Let me creating a slice with make. Okay, so where was I? So let's create a new node. Where is it? forget. So in Rebel navigation, new note. Let's call this index. So where was I? Last time I was in slices. Did I create an index here? Fuck off. Slice length and capacity. I mean, nil slices. I mean, obviously, what the hell is that? I don't know. Let's just create a, hold on it. Nil slices. And then creating a slice with a make. No one's gonna fucking use it, bruh. Slices of slices, who gives a slice? Appending to a slice. Then range. Okay. Range. Range. This. Range continued. What the hell? Range. You can skip the index or value by assigning to range power. If you only want the index, you can omit the second variable. If you only want the index, why would I want the index, bruh? So if I have the index, I can just manually get the value from the array, from the slice. So make. So here, what they are. So let's just say a number, and essentially I am creating a slice with 10 element make. So that's the length, this is the type, this is the length, and var I range number. So this is gonna give us the index, just index, and just like I thought, we can access element, and what the hell is this? 2 power I. So this is gonna just push some nifty bitwise operations or something on an integer. So this pushes some values, and now I get the value range number, and then I print just a number. Print f. Just print the value, bro. Okay, what is going on? Why did it take so long to run? The first compilation took forever. This took a second to run. Wow. So yeah, unsigned integer. Oh, bruh moment. Okay, range continued. What are we doing? So here we just learned how to, we can, if we omit these two values, only use one value, we get the index, and we can omit the other value by using this syntax, weird looking syntax. Exercises, get out of here, man. Maps. A map maps keys to values. The zero value of a map is nil. A nil map has no keys, nor can keys be added. The make function returns a map of the given type, initialized and ready for use. So we got a type latitude and longitude, which is float 64. Okay, let me just create a type user outside this type user struct here as name string and age number. Fuck, not cool. Int. And then we're describing m, which is a map string of, what is this? Oh, key value pairs. Key value. Okay, user. This is kind of cursed territory. We are reassigning the value. Okay, make map string user. Oh. User first name age 24. fmt print ln m. Okay, a map maps keys to values. A zero value of a map is nil, and nil map has no keys, nor can keys be added. The make function returns a map of the given type, initialized and ready to use. So yep. So we got a struct. We create a struct, and then we initialize a map with type like vertex or something. We initialize a map. I think map string is necessary. It initializes this, and it's not initializing but declaring. That's the word. Okay, so we call make, and we pass the same thing, right? I don't know why we are doing it. And then we do that, and let's see. Text number imported and not used. The fuck is that? Okay. My questions are, what is this cursed syntax? What's this cursed syntax? Create a user struct value, okay, and assign it into the map. Okay, cool. Struct a definition, blueprint for the user. Create a map string to user. Cool. String to user. How the fuck am I supposed to know that, bro? Doesn't really tell me anything, bro. Id enable this. Object. Create map. Okay. Struct literal. Construct a user value. Equivalent. Okay. Safer named. Okay, because field starter doesn't matter and it's more readable. Entire thing. Okay, okay. Um, okay. Let's just cut this and paste this. Is that really necessary? This statement crashes. What the hell? Make a map. Okay, var map string user. Okay, we create a variable of map that takes in string and user. Key is string and value as user. Holy shit. How do I syntax? Ah. Okay, runtime initialization, got it. Copy this. Wait for it. Index, damn it. Navigation, how to use make in creating map. Okay, cool. All right. So we got a map. So first we declare the make. So this creates this is a map type. Make initializes and creates it, and then we add it. We can reduce it, but the 0 value of a map as no keys now can be added. The make function returns a map of the given type, initialized and ready for use. Cool. Map literal. Okay, map letters are like struct literal, but the keys are required. So this is the map literal. All right. So to create map literal, let's just so we create var m and then give it the type text the string as a key, I believe, and the user as the, and then we can enter it. We can enter a lot of key value pairs now. Okay, now we say and then initialize it like so. And then a number, let's say like this, and also need that. Also need comma here. Dimd. Right. Kind of useless. All right, now we got the map. Let's print it. Okay, we got a map. Cool. Map literal. Uses the map type, and then in the braces, so we pass key and value, key and value. Map literal. If the top level type is just a type name, you can omit it from the elements of the literal. So yep. Apparently we can do that. Like what is going on? What is this? Var. If the top level is just a type name, you can omit. Don't understand it. What do they mean? The main goal is to omit the repeated type name when it already knows the accepted type. I unconsciously left it, bruh. Okay, like go to back. Okay. My Jesus Christ. I was supposed to use the like this. Bro, I didn't know that. Mutating maps. Insert or update an element in the map. Okay. Key, value. Cool. Jesus Christ. These maps are just Okay, let's just delete all of this. Insert or update map, retrieve an element, delete an element, test that key is present with two value assignment. If key is in M, OK is true. If not, OK is false. If key is not in the map, then element is 0 value for the map's element. If element O or not yet been declared, you can use a start declaration form. Great. Okay, first insert and update an element. Okay, first let's create a map. Let's create a map. We're gonna use the syntax like var like this, but we can use them like make text a map, always string, and int. Okay, and now let's see, answer. We added 1. Easy. So that's how you use the element. Now let's print fmt, print ln m, and then now retrieve an element. So we can assign another element. So n let's see, m dot answer, m answer, print fmt, print ln n, and then delete an element. So delete m key answer. Test that the key is in present with two value assignment. So we deleted it. Now let's print it. Print fmt, print ln m. Now assign it. Let's assign m value answer. We can recreate it. Now it's 2. Print it again, and now check if exists lm. Okay, m answer. Okay, now we fmt print ln lm. Okay, all right, go. Map 1, map empty, map 2 to true. Bullshit. Let's use some bullshit value. Should return false. Function values. Functions are values too. They can be passed around just like other values. Function value may be used as function arguments and return values. Okay. What is going on? Function compute function a fn, a variable of type function that takes a float and returns float, and then float. This returns float. A high part variable is created. It has a type. It's a function type func xy floats, returns float, return math square root, high part, compute high part. All right. Okay. let's create a function. Function say greet that takes a user, which is a string, and returns a string, and returns user plus let's say hello. All right. Let's say flag hello takes a function which is of type func type string, return string, and then calls what the fuck am I supposed to do, bro? Like, just calls returns. I'm supposed to pass a string here. Say like here, I don't know, bro. And now we can just call it hello. It's not exactly printing it, so fmt print hello and pass greet. Boom. Obviously need to add a space. Function closures. Go functions may be closures. A closure is a function that function value that references value from outside its body. The function may access and assign to the referenced variable. In this sense, the function is bound to the variables. For example, the adder function returns a closure. Each closure is bound to its own some variable. Right. What do we got? We got position and positive, negative, or something. Adder. They both take a function. Function adder returns another function that takes int and this. So we got a sum declared and returns a function int and sum plus x. Very weird looking thingy. So mutating maps. Okay. Let's see. Index range map literal mutating maps. And then what we got? Mutating function values. Function values. Function closures. Function closures. Really like very complicated, I think. Tab. So essentially it returns a function, but what we got? Returns a function. Returns a function that returns a, what is this? Okay, calling this returns a function. So essentially these value. And then calling them this just takes a value and repeatedly adds it. Repeatedly adds positive value, repeatedly adds a negative. So yeah, 0 1, the next 2 2. All right, very cool. Fibonacci closure, get out of here, man. Methods. Whoa, where are we, dude? Methods are function, methods continued pointer receiver interfaces, readers generic concurrency. Shit, bruh. Very cool. Methods. Hello? So I forgot to record. This is how you create the methods. So, yep. Methods pretty like this is how a method looks like. So you create a function and then this a function apparently when we do that they're called this method name. This method name and this is argument list and the return type. But between method name and the func keyword inside the parentheses you can you know tell the compiler whatever the receiver. So here I'm using the receiver user and I can access its values. And yes, Go apparently does not have classes. This does look like something a class would look like. Like you would probably create a class. It maybe has a constructor or inside a class you create methods. Go does not have it. So every time I create a method, it's gonna look very weird. Methods are functions. Method is just a function with a receiver argument. Here's how apps return as a regular function with no change in functionality. Okay, they are using capital letters. I did not notice that. And yep, instead of using this syntax, they are just taking in the the receiver, like they take an argument and they act an argument. Seems like a regular function. You can do with a regular function. You can declare a method and a non-struct types too. In this example, we see a numeric type myfloat with an apps method. So we got a type. What the hell? We got a type. We did not instantiate it, but takes the float, and if f is less than 0, returns float, returns a float of the value, returns float-x. What is this? What is the point of it? Takes a float, I mean apps method. You can only declare a method with a receiver whose type is defined in the same package as the method. You cannot declare a method with a receiver whose type is defined in another package, which includes the built-in types such as int. pointer receivers. You can declare methods with pointer receivers. This means the receiver type has the literal syntax for some type t. Also, t cannot itself be a pointer, such as asterisk int. A pointer. So this is the normal, and this is the pointer scale. Even though we are using pointers, we can just use it like normal. That's just how Go allows us. Methods with pointer receivers can modify the value to which the receiver points, as scale does a year. Okay, we are modifying it. Since the methods often need to modify the receiver, pointer receivers are more common than value receivers. Try removing the asterisk from the declaration of the scale function on line 16 and observe how the program's behavior changes. With a value receiver, the scale method operates on a copy of the original vertex value. This is the same behavior as for any other function argument. The scale method must have a pointer receiver to change the vertex value declared in the main method. So we get vertex and the scale. So scale print apps function. Okay, let's run it. 50 vertex scale 3 4 apps function. Apps function takes the value and multiplies it. So we get 3 times 3. What's 3 times 3? 9. What is 4 times 4? 16 or something. 16 plus 9. 16 plus 9. Let's do calculator, bro. 16 plus 9. 25 times. Okay. And then vertex scale by 10. Wait a minute, like this. What the hell? Can I just fucking print the value, bro? I am a kind of a, print ln. Bro, okay. Do me a favor, print it. Okay, what the hell? What the hell? What the hell? Scale. We call the scale this scale by 10. So it is doing something. So we are just instantiating it, but we did not call apps. So scale runs before apps. When we write down, these are just instantiated. So 10 3. So the value f, where is f? Scale f 3 times well, let's see, 3 times 30. So we got 30 and 40. Okay, let me also print t print ln v dot x and v dot y should give us the value. So 30, 40. And what is this? Square root. Gonna like take the square root. That's why it's kind of small pointer receivers. So the point is the methods you can declare like the syntax kind of takes in a pointer instead of value. Pointers and functions. Here we see absence scale methods return as functions. Again, try removing the asterisk from line 16. Can you see why the behavior changes? What else did you need to change for the example to compile? So it's not compiling. What the hell? Again, vertex scale bruh. Methods and pointer indirection. Comparing the previous two programs, you might notice that function with a pointer argument must take a pointer. Compiler, okay. While methods with pointer receiver take either a value or a pointer as the receiver when they are called. Var vertex scale 5, okay. P scale for statement v, even though v is a value and a not uh, even though v is a value and not a pointer, the method with the pointer receiver is called automatically. That is as a convention. Go interprets the statement as a scale, since scale method has a pointer receiver. So this a normal function with pointer receiver type like throws a compile error if you throw a value instead of a pointer, but pointer methods work. Just work, bruh. With methods and pointer in direction too. The equivalent thing happens in the reverse direction. Function that take a value argument must take a value of that specific type. Oh, same thing. While methods with value receivers take either a value or a pointer as the receiver when they're called. So we get a vertex and we pass apps value, okay? And p, which is a pointer, and we call apps on it. Also fine. In this case, the method call is interpreted as like this. Cool. I think the Go already does it. Choosing a value or pointer receiver. There are two reasons to use a pointer receiver. The first is so that the method can modify the value that its receiver points to. The second is to avoid copying the value on each method call. This can be more efficient if the receiver is a large struct, for example. In this example, both scale and apps are methods with receiver type vertex, even though the apps method need modify its receiver. In general, all methods on a given type should have a given type should have either value or pointer receivers, but not a mixture of both. We'll see why over the next few pages. So yeah, we got a vertex pointer method before calling. What is this? Before calling, so these are like values. V before calling 3 4 apps 5. So apparently that's how you print a pointer or something. So this is a pointer address. This just prints the value of that address. So either use the interfaces. process.